Automating Kubernetes deployments with GitHub Actions. Hey everyone, and welcome back to the channel. If you've ever felt the pain of manually deploying your applications to Kubernetes, juggling Docker builds, image pushes, and kubectl commands, you know it can be a time-consuming and error-prone process. Imagine a world where a simple code commit automatically triggers a robust pipeline that builds your Docker image, pushes it to a registry, and deploys it seamlessly to your Kubernetes cluster. Sounds like a dream, right? Well, today, we're turning that dream into reality. In this video, we're going to dive deep into automating Kubernetes deployments with GitHub Actions. We'll walk through creating a complete CI/CD pipeline that handles everything from code commit to live deployment. By the end, you'll have a clear understanding of how to set up your own automated workflows, saving you countless hours and reducing deployment headaches. Let's get started. Manual deployments often lead to inconsistency, human error, and slow release cycles. Picture a developer frantically copying files, SSHing into servers, and running commands manually. One typo, one missed step, and your application could be down, leading to frustration and lost productivity. This traditional approach simply doesn't scale in today's fast-paced development environment. This is where continuous integration and continuous delivery, or CI/CD, comes in. It's not just a buzzword, it's a methodology that transforms your development lifecycle. CI/CD automates the build, test, and deployment phases, ensuring that your code is always in a deployable state. It leads to faster releases, higher quality software, and ultimately, happier teams. By automating, we gain consistency, speed, and reliability, paving the way for true DevOps efficiency. At the heart of our automation today lies GitHub Actions. If you're not familiar, GitHub Actions is GitHub's powerful, event-driven automation platform. Think of it as a set of Lego bricks for building your software workflows, right within your GitHub repository. The core components you need to understand are workflows, jobs, and steps. A workflow is a defined automated process, typically stored as a YAML file in your repository. It's triggered by specific events, like a code push or a pull request. Inside a workflow, you define one or more jobs, which are sequences of steps that execute on a runner, essentially a virtual machine provided by GitHub. Each step is an individual command or an action, a reusable piece of code, that performs a specific task, such as checking out code, building a Docker image, or running a kubectl command. It's this modularity that makes GitHub Actions incredibly flexible and powerful for CI/CD. Our CI/CD pipeline for Kubernetes deployments is a carefully orchestrated sequence of steps, designed for efficiency and reliability. Let's break down the journey our code will take. First, a code commit to our main branch initiates the entire process. This is our trigger event. Next, the pipeline will perform a Docker image build, taking our application code and packaging it into a portable Docker container image. Once built, this image isn't just sitting locally, it needs to be accessible for our Kubernetes cluster. So, the third step is to push this Docker image to a registry, specifically Docker Hub in our case. Finally, and most crucially, the pipeline will execute the Kubernetes deployment, taking our newly pushed image and updating our application on the Kubernetes cluster. This entire sequence happens automatically, ensuring your changes are deployed swiftly and consistently, every single time. To make this demo concrete, we've structured our project repository to be clear and modular. You'll find 3 main directories, each serving a distinct purpose. The app/directory contains our simple Node.js Express application. This is where your actual application code resides, along with its package.json4 dependencies, and crucially, the Docker file, which defines how to build our application into a Docker image. Next, we have the K8s/directory. This is home to our Kubernetes manifest files, specifically deployment.yaml and service.yaml. These YAML files declare the desired state of our application within the Kubernetes cluster. Finally, and central to our automation, is the .github/workflows/directory. Inside, you'll find main.yml, which is our GitHub Actions workflow definition file. This single YAML file orchestrates the entire CI/CD process, from building to deployment. This clear separation of concerns makes the project easy to understand, manage, and extend. Now, let's dive into the core of our GitHub Actions workflow, starting with the build and push job defined in our main.yml. This job is responsible for transforming our application code into a deployable Docker image and making it available. The workflow is triggered on push to the main branch, meaning every time you commit and push changes, the magic begins. It runs on Ubuntu latest, leveraging a fresh Ubuntu virtual machine provided by GitHub for each execution. The steps within this job are straightforward. First, actions/checkout at v4 pulls our repository code onto the runner. Then, docker/setup builds action at v3 is used, a best practice for modern Docker builds, ensuring efficient and robust image creation. Crucially, the docker/login action at v3 step logs us into Docker Hub using secrets, $secrets.docker_username, and $secrets.docker_password. These secrets, which we'll configure later, keep our sensitive credentials secure and out of our public code base. Continuing with the build and push job, the next vital step is docker/build push action at v5. This powerful action takes care of both building our Docker image and pushing it to Docker Hub. We specify context, /app, telling Docker where to find our Docker file and application code. The push, true flag ensures the built image is immediately uploaded to our configured Docker Hub repository. For tagging, we use a highly recommended strategy, $env.docker_image_name_env: github.sha. This dynamically tags our image with our defined Docker image name and a unique identifier based on the git commit SJ. This approach guarantees that every single build is uniquely identifiable and traceable back to a specific code commit, preventing conflicts and enabling easy rollbacks if needed. The step also outputs the full image name and tag, which will be essential for our subsequent deployment job. This ensures that the exact image we just built is the one we attempt to deploy. With our Docker image built and pushed, it's time for the deploy job, which brings our application to life on Kubernetes. This job is configured with needs, build and push, meaning it will only execute after the build and push job has successfully completed. This ensures a proper dependency chain. The first crucial step here is to set up kubectl, the Kubernetes command line tool. We use Azure/setup kubectl at v3 to install a specific version, in our case v1.28.0, ensuring compatibility. The most critical part for connecting to your cluster securely is the configure kubeconfig step. Here, we take our base64 encoded Kubernetes configuration data, stored securely as the kube_config_data GitHub secret, decode it using base64d, and write it to the standard Kubernetes configuration path, /kuba/config. We also set chmod 604 appropriate file permissions. This secure and dynamic kubeconfig setup allows our GitHub Actions runner to authenticate with your Kubernetes cluster, without ever exposing your sensitive config directly in the workflow file. Once kubectl is configured, our deploy job proceeds to prepare and apply the Kubernetes manifests. The first step, replace image tag in Kubernetes deployment YAML, is ingenious. Our k8s/deployment.yaml uses a placeholder image tag, your Docker username /k8s, node, app, latest_image_tag. This step dynamically replaces that placeholder with the exact image tag we just built and pushed, which includes the unique Git chain.